This is the given system. Initial conditions are given. Okay, then we need to solve using diagonalization. Point to be noted here, see, if diagonalization it is mentioned, then only you have to apply this treatment. Otherwise, whenever you have this type of problem with the initial condition, immediately go for Laplace. Okay, unless it is stated in the problem, immediately we will apply Laplace and try to solve. Because if you are going for diagonalization process, then this type of questions, they are little lengthy to solve. Okay, so better it is recommended apply Laplace if initial conditions are given. So let's try to solve this question using this method, because it is mentioned, and you should also know the technique by which one can easily solve this type of question. First thing, you should note down that this is a homogeneous type of equation, and we can write this system. Suppose this is system number 1. So 1, it is equivalent of writing d2x dt2. It is here, if you simplify this, it would be minus 5x plus 2y, and d2y dt2, that is 2x minus 5 or minus 2y minus 2y. Okay, so this is the given system. Obviously here x, it is nothing but xt, y, it is nothing but yt, function of t. So it is an autonomous system. Now see, this system can be expressed as suppose here u double derivative. Okay, u double derivative, u double dash a u, where u, that is ut, it is nothing but xt yt, and a, it is the corresponding coefficient matrix, that is minus 5 to minus 2. Okay, and under this setup we need to apply the diagonalization process. So we need to apply diagonalization. That means we need to diagonalize the matrix A, then we can proceed further. So first step one, find eigenvalue, and corresponding eigenvector. Okay, corresponding eigenvectors. So for that, first thing will be to write the characteristic equation. So a minus lambda I, that is equal with 0. So from here, if you do the calculation, you will get, see, minus 5 minus lambda, here 2 minus 2 minus lambda, here 0. So you try to simplify this one, you will be getting 5 plus lambda, 2 plus lambda, minus 4 equal with 0. So here lambda square plus 7 lambda plus 6 0. So lambda value minus 6 and minus 1. These are going to be lambda value. Okay, now next step is what? Find eigenvector. So for lambda is equal with minus 6, if you want to find the eigenvector, so a minus of minus 6, that is 6i, suppose v1. Okay, v1 is one eigenvector corresponding to that. So here that is equal with null vector. So if you solve this one, you'll be getting minus 5 plus 6, so 1, here 2 minus 2 plus 6, that is 4. Here suppose v1 you are getting, so suppose v1 suppose v1 bar, v1 double bar. Okay, these are the components. You can write anything. Suppose in place of v1, if you want to write suppose capital V here, v1 v2, okay, that you can write as per your choice. These are only notational difference, nothing else. So 0 0. So here v1 bar plus 2 v1 double bar, that is 0. So from here you can write this v1 here. See, from here what you are getting, v1 bar, that is minus 2 v1 double bar. So suppose you are taking v1 double bar, it is k, immediately v1 bar will be minus 2k. So you can put k equals to 1 and immediately you will get 1 minus 2, that means minus 2. See what I am trying to say here. Say let v1 double bar, it is k, scalar, non-zero scalar. So immediately v1 bar will be minus 2k. As per this setup, minus 2k and k will be eigenvector. So if you put for k equals to 1, what you get, minus 2 1. So you can say this is v1 minus 2 1. Okay, it's possible, fine. This is one eigenvector, is one eigenvector corresponding to this particular eigenvalue for lambda equals to minus 6. Similarly, if we apply the technique, so for lambda equals to minus 1, if we apply the technique, so what you will get, a plus I v1. Suppose here we are taking v2 null vector. So just the same technique if you apply, you will be getting, after doing this calculation, should perform the calculation, you should get v2 as 1 2. Okay, so this is v1 and this is our v2. Now step 2 formulate p, okay, d. Okay, so p, it is given by, you just write the vector here. So minus 2 1 1 2, this is going to be p, and d is what, the diagonal matrix. Okay, so the diagonal matrix is minus 6 minus 1, here 0 0, is d. So once you have this p, so immediately we can find p inverse as well. It will be required in the subsequent steps. So if we want to find p inverse, so first determinant, that is minus 5, here adjoint, here minus 1 minus 1, so that is nothing but 1 by 5 minus 2 1 1 2. So this is going to be p inverse, this is p and this is d. Okay, now we are going to apply one important concept which already we have studied in our previous sections as well, in the diagonalization part particularly you will find in that lecture. So now here you can see in the step 3, let us take a transformation. Let u is equal with p z. Okay, u is equal with p z. So if you apply this transformation in the given problem, that is, in other words, you are saying ut will be transformed as p into zt. Okay, where obviously where zt, it is z1t and z2t. Alright, now from here if you find u double dash t, that is going to be p z double dash t. Okay, p is a matrix which already we formulated. Now the given question is what, u double dash t is equal with a into ut. This is the given problem. So in place of u double dash you will put p double dash t a ut, and in place of ut, just now we considered this transformation p into zt. This technique already we studied in our simple diagonalization method. Okay, now z double dash t, here p inverse a p zt. Okay, because see a is diagonalizable. Why? Because a has two distinct eigenvalues. So a can be expressed as AP is equal with PD, that is A is equal with PD, P inverse, or in other words D can be expressed as P inverse AP. Okay, so we have these results. Now P inverse AP, that is nothing but D into ZT. So what we have, Z double dash T, that is this one, and D is diagonal matrix. So what we have exactly, see, Z1 double dash T, Z2 double dash T. Here D means minus 6 0 0 minus 1, Z means Z1T, Z2T. Now if you do the calculation, you will be getting, see, Z1 double dash T, that is minus 6 Z1T. Here Z2 double dash T, that is minus Z2T. So if you individually try to solve these two expressions, so from here, see, this equation Z1, individually we can take these two equations. So what we have, see, so for Z1 double dash T, that is minus 6 Z1T. Here this is simple second order equation with constant coefficient. Now here you can see Z1T is equal with 0, so we can introduce CFPI form. So immediately Z1T will be A1 cos root 6T plus B1 sin root 6T. Okay, so this is Z1. Similarly for Z2 double dash T, it is minus Z2T. So from here Z2T, it is going to be A2 cos T plus B2 sin T. Okay, Z1 and Z2. Okay, so from here what we have as ZT, it is A1 cos root 6T plus B1 sin root 6T, and here A2 cos T plus B2 sin T. Okay, now here these are the constants A1, B1, A2, B2. These constants we need to evaluate using the initial condition. So what we have as initial conditions, so at t equals to 0, Z0, we need to find Z0. So the value it is A1, and here we have A2, and two conditions are given, so we can find Z dash T as well. So Z dash T, that is minus root 6 A1 sin root 6T plus root 6 B1 cos root 6T. Okay, this one you have, and here minus A2 sin T plus B2 cos T. Okay, so here Z dash 0 also one can easily determine, that is given by here root 6 B1, here B2. Okay, now we are in a position to apply initial conditions. So initial conditions are given as U0, it is U is equals to P ZT, so Z0. Okay, so U0 means it is X0, and here we have Y0. So P value, P, what is P? That P already we got minus 2 1, so minus 2 1, and I guess it is 1 2. So if you apply 1 1 2 here, so Z0 it is A1 A2. So X0, the values are given, X0 and Y0, the values are given in the question. So X0 value it is 1, Y0 value it is 2. So you can apply these values. It is 1 2 here to the multiplication, 2A1 plus A2, similarly A1 plus 2A2. you solve, minus 2a1 plus a2, 1 a1 plus 2a2, 2. If you try to solve this one, what are the a1 and a2 values? See, multiply the first equation by 2. So here multiply the first equation by 2. So minus 4a1 plus 2a2 is equal with 2. Here you are getting a1 plus 2a2 is equal with 2. Just do the subtraction, you will be getting a1 is equal with 0. So a2 is equal with 1. Okay, so these are a1 and a2 value. Similarly, if we apply u dash 0, so it is p z dash 0. So here u dash 0, just put the values, which is this one, minus 2 root 6 and root 6. So here minus 2 root 6 and root 6. Here the values are minus 2 1 1 2. Here root 6 b1 and b2. So if you further do the calculation, so you'll be getting this one, root 6. Here minus 2 root 6 b1 plus b2. Similarly here root 6 b1 plus 2 b2. So likewise, if you do it, finally the values for b1 and b2 you are getting. So here you can do the calculation here. So minus 2 root 6 b1 plus b2, that is same as minus 2 root 6. Here root 6 b1 plus 2 b2, that is root 6. So just multiply the second equation by 2 and then add. So you'll be getting b2 is equal with 0. b2 is equal with 0. Okay, so b2 equal with 0. So here b1 will be 1. So again we are getting these two values. Now back substitute in the main expression. So what you are getting, see, now z1t, it was earlier, see what is the expression, z1 equals to a1 cos root 6 plus b1 sine root 6, a1 0 b1. Okay, so basically sine root 6 it will be there, sine root 6 this part, and here a2 equals to 1, so cos t. Okay, so z1 equals to sine root 6t and z2 is equals to, I guess, cos t. Yes, cos t. Yeah, so b2 value already we got as 0. Now this is the final form for z1 and z2. So that is zt, we can write sine root 6t cos t, and here what we have, ut, this is our target, p zt. Now p already we know, minus 2 1 2 1 and 2, and here we have sine root 6t cos t. So if you further solve this, minus 2 sine root 6t plus cos t, here sine root 6t plus 2 cos t. So finally the solution, that is xt is equal with minus 2 sine root 6t plus cos t, and yt, it is sine root 6t plus 2 cos t. This is the final solution. Okay.